Hi students, today I try to explain another problem, that is second question. I can read this question first of all, then we can discuss how to solve this question. A pair of spur gear has to transmit 20 kilowatt from a shaft rotating at 1000 rpm to parallel shaft which is to rotate at 310 rpm. The number of teeth on pinion is 31 with 20-degree full depth involute tooth form. The material for pinion is steel SAE 1040 and treated with allowable static stress of 206.81 megapascal, and the material for the gear is a cast steel of 0.2% carbon untreated with allowable static stress of 137.34 megapascal. Determine the module and phase width of the gear pair. Also find the dynamic tooth load of the gear. Take the service factor as 1.5. Okay. So first of all we can explain what are the given data in our question. And the power is given, that is 20 kilowatt, as already we know that the power is denoted as P. So we can write P is equal to 20 kilowatt. And next one, here the speed of the driving and driven shaft is given, that is the shaft is rotating at 1000 rpm to a parallel shaft which is to rotate at 310 rpm. So we can write N1, that is the pinion as 1000 rpm, speed of the pinion as 1000 rpm, and speed of the gear as 310 rpm. Then next one, they are given the number of teeth on pinion, that is equal to 31. We can write it as a Z1. Z1 is equal to 31. And here we can see that it is a full 20-degree full depth involute tooth form. So this is particular case that given in the question itself, the form of the teeth. Okay, so we can take the alpha is the pressure angle, that is we can take it as a 20-degree full depth involute, and sigma d1, the material for the steel. Material for pinion is a steel, that is equal to SAE 1040. In this question, the material for pinion and gear are different. The material for the pinion is steel, and material for the gear is cast steel. So, firstly, we can identify that these are not same material. So, we should check for the strength factor. Okay. So we can mark, in this case, the value of static stress is directly given in question itself. For a pinion, it is 206.81 megapascal, and for a gear, it is 137.34 megapascal. That shows, that is, here in this question, the value of stress is directly given, but some cases the value will not given in our question, so we can take it from our table that I discussed in the previous section. Then the question is to determine the module. Next one is phase width. Okay. Then also find the dynamic tooth load, that is FT. So FD, not FT, dynamic tooth load, that denoted as FD. And next one is a given data, that is the service factor. We can write it as CS, that is equal to 1.5. Okay. Then we can start our solution. As already we know that the value of I, the I stands for, what is that? I stands for speed ratio or velocity ratio, that is equal to N1 by N2. That is again is equal to, according to the diameter, we can write it as D2 by D1, that is inversely proportional. Also the number of teeth comparison, or the ratio of the number of teeth, again N1 by N2 is equal to Z2 divided by Z1. Then using that equation you can find the value of Z2, that is equal to 3.23, that is the value of I, into 31, that is 100 teeth. Don't take any decimal value for number of teeth, so take a round figure itself. Then step 1, identify the weaker part. How we can identify the weaker part? First of all, we have to find the strength factor, that's equal to sigma d into y. Here sigma d1 and sigma d2 we already write in our given data section. And next one is y. What is y? Y we can take from our data book. So you can take your data book using this equation. the value of y is equal to 0.154 minus 0.912 divided by z. You can take this equation for the alpha is equal to 20 degree full depth involute system. Okay. So using this equation you can substitute the value of z1 and z2. z1 for y1 and z2 for y2. Thus you can find the value of y1 and y2. So take the value strength factor for pinion and gear. Take that value sigma d1 into y1, that is equal to 25.77 megapascal, and for gear sigma d2 into y2, that is equal to 19.97 megapascal. So which one is lesser? The lesser is for the gear. Okay, so the design is based only on gear, not for pinion. So we have to design a gear. Then next section we can find module. In the first section is what is the value of module. So using this equation, that is m is equal to cube root of 2mt divided by sigma d cv k y z. Using this equation you can find the value of m. You can take that equation from your data book itself, but this equation is not given in our data book. P is equal to 2 pi n mt divided by 60. Here we are using n2 because we are using n2. The design is based only on gear, so we are using n2. So after this section we use only the gear section only, not any pinion section. So take the value n2. Thus you can find the value of mt. Then assume the value of k. Okay, some assumptions we need to take to complete that question, complete this answer. Assume k is equal to 10, that is equal to b by m. It is already given in our data book. And next value cv, it is not assumption, it is given in the question. Cv is equal to, sorry, it is assumed value. Cv is assumed value, cs is directly given in our question. Assume cv is equal to 0.5. now we can assume, after some time I can show how to take that value from our calculation. The next one, form factor. What is the value of form factor? Y is equal to pi into y2. Why we take y2? Design is based on gear. Okay, using this equation we can find the value of module. Take that value, m is equal to 3.4 mm. Take your calculator and solve this value. From your calculator itself you have to find this value, otherwise we cannot solve it in our exam, because during our exam time, because the calculator, the functioning, we have to identify how to solve the cube root, how to solve the power of 3 or power of 2 equations. Okay, then after that we can standardize our module value. What is that value? Standard value is m is equal to 3.5 mm. You can take it from the table. So table 12.2. Please refer the table 12.2 and page number. From the table you take the upper value, not go for a lower value. It is 3.4. So take upper value as 3.5. Okay. Then using this equation, we already know that the module is the ratio of diameter to the number of teeth. So using that equation we can find the value of d1 and d2. Also face width, that is already we calculated as b is equal to 10 into m. So these values we can find out d1, d2 and b. Next we can check the value. cv we assume check for sigma d2. We know that ft, ft equation we know, that is from our data book, that is equal to pi into sigma d into cv into b into y into m. Okay, but here we can take the value v is equal to pi into d2 into n2 divided by 60. That is pi dn by 60. That equation we know. Here we are using, because the design is based on gear, so d2 into n2 divided by 60. So using that equation we will get the value of 5.681 meter per second. Again you can take your data book, and there are a lot of equations. 12.19a for the value of cv. We get the value of cv is equal to v is equal to 5.68. that is, we can take that equation from this condition, that is v equal to 8 meter per second, less than 8 meter per second. cv is equation, this one. Using that equation cv is equal to 0.349. okay, So then ft is equal to 2 mt divided by d. Here we can use the equation cs, that is the not equation, that service factor. So we can use that service factor here, and using that equation find the value of ft. Find the value of ft. Then this shows that using this section we can compare the value of sigma d2, that is sigma d2 is equal to 271.34 megapascal, which is not less than 137.37 megapascal. Okay, so this design is not safe. So with that module the design will not save. So how we can calculate the other section? We have to reschedule, that is hence change the module value. Okay, that section I can show now. That is, next we adopt the next higher value. Somewhat I think we can take it as a module as 5 mm, and we can do the same section that we do before once more. At that time we will get the value of v is equal to 8.12 meter per second. So at that time we can take the values, the CV as next value, that is v is greater than 8 meter per second, CV is equal to 4.58 divided by 4.58 plus v, that is equation number 12.19b. And using this section we can find the value. Again we can find the value of sigma d2. That value is equal to sigma d is equal to 90 megapascal, which is less than 137.34. So we are safe now. So now the design is safe. Then we can go for next step. Find the value of phase width. Phase width is denoted as b. B we already calculated using this equation, using the previous section. That is b is equal to 50 mm. That is b in k into m. K is equal to 10, and now it is the value of m is equal to 5. So 10 into 5, that is equal to 50 mm. Then next or last one, find the dynamic tooth load FD. FD we can take this equation from our equation number 12.33 in the page number 166, and take the value of FD is equal to K3 into V C into B plus FT divided by K3 into V plus root of C into B plus FT. The value of K3 is already given in the datebook, just below the equation, that is K3 is equal to 20.67, and all other value we can take directly from the databook. So you can use these equations and find the value of FD. So you will get So you will get the value of FD is equal to 19.30 kilonewton. I think you should write this question, and you have to solve with your calculator and your data book in your data book. Then please send it as a comment after the solution. If you have any doubt, please contact directly.